we would like to introduce our next presentation, and I just misplaced the schedule of the presentation, and now it's the turn of Oleg from Bulgaria. He worked in an Antarctic expedition, in a Bulgarian Antarctic expedition, and he made a lot of very important job in Antarctica with drones, for accurate survey. Oleg, hello once again, and I invite you to make a presentation.
Hello, Maxim. Thank you very much for your invitation. I'm glad to share what I and my team achieved for the last two Antarctic campaign, starting from 2017 and up to 2019. You are as a base photo. You can see a typical relief of one of the South Shetland Islands called Livingstone. This is nearby the Antarctic Peninsula, which is easily seen in the distance, far distance. The geology is mainly volcanic rocks, and this is the reason why we have such a variety in a very small distance scale. The highest summit seen on this photo is about 2,000 meters, nothing special, especially for people from Europe. But combined with the hazardous Antarctic weather, it could accumulate a lots of surprises. As I already said, this is the topographic map of Livingstone Island with very remote areas. The areas painted in green are usually clean from ice and snow during the Antarctic summer. Antarctic summer starts at the end of November and finish in the beginning of April. So the area in green are usually almost clean from ice and snow during this period and are very, very attractive for different kind of surveys. Biologists, marine biologists, geologists, glaciologists, people who are monitoring the dynamic of the glaciers. This is where my experience is most focused on. I produce a different precise survey, firstly made with a stock DJI Phantom 4 Pro, and then well upgraded with the aim of TOPODRONE. So the area painted in red are covered by PPK solution from TOPODRONE, and the area painted in blue are with the normal stock DJI Phantom 4 Pro. This area covers 15 square kilometers. I prepared some photos to illustrate what are the levels we are trying to reach, or what is the target for the research. First of all, a very intensive work on different glaciers for producing a high and detailed survey for the dynamic changes of the glaciers. It is concerned with the global warming. It is concerned with the real change of our understanding how the glaciers are formed and how the glaciers are evaluating. The success of this work is mainly based on the precise map, creating a precise map and updating this precise map. When I'm talking about a precise map, I'm talking about a surface model, but we mainly play with a dense cloud. And based on the comparison with the different dense clouds within the time, we're able to read the dynamic of the surface. Another thing which is good to mention is that Antarctica and including the South Shetland Island, they are out of the coverage of SRTM service. So SRTM shuttle topography is not available at this place. So in order to fly with a fixed altitude above the terrain, you need to create your own digital elevation model. At the end of 2018, a digital elevation model for Antarctica was already available, but the resolution of this model is about 50 meters in each direction. In either way, this model is not suitable for precise research, whenever the ground sampling distance of 1 centimeter is absolutely necessary. Another thing that I would like to mention is that with the aim of PPK solution, it is very affordable to produce a photogrammetry model of a remote site, remote in terms of far away from the takeoff point. And here we could see an idea of using PPK. You're more or less concerned with this, where we have a drone working as a rover and the base station where the connection between them is not necessary. Here is a typical photo from our field work. You can see lots of crevasses facing on the glacier level. The usage of drone is very useful in terms of orientating in the way how to approach to the takeoff point in order to avoid crevasses. So it means safety and it means efficiency. And secondly, it is very convenient when we place these markers. There are some tension, there's some measurement devices which measure the tension, and we used to read them with the Wi-Fi devices, so they could show the fine cracks which happens within the several minutes or several hours, depends on the environment and depends on the angle of the slope. Another perspective of the field work. In order to have an idea how the drone is helpful for getting to the job site or to the field work, I took a short video where you can see the area of collapsing of the glacier, and as we were able to observe the geometry of the crevasses, we feel quite comfortable to walk over the terrain and to have an access to the very dynamic part of the glacier. And then you can see three of us at a distance. Another glacier which we put on focus in 2019, where the dynamic is much more emphasized, this is called a shelf glacier. This piece of ice lay on the surface of the sea, and the dynamic is not so high. Another good example of a field work is monitoring of a penguin colony, where we have to deal very gently with the disturbance. So we have to avoid disturbance of the nesting birds or the rising or the chickens, and at the same time we have to be quite clear with the gathered information, acquired information, in order to determine several parameters like the density, the distance between the nest, the age where the chicks are leaving the nest. Usually we perform about 30 sequential flights within a campaign. This is an example of how we can approach the job site, not an easy way, and that is why we are limited to the amount or the type of drones we are able to carry on during the mission. Normally, normal users, or in most of the cases, people used to fly at a fixed height above the control point, above the takeoff point, and it produces a variable scale factor, especially when the terrain is has a complicated topography. With this slide, I would like to explain why the necessity for having a ability to fly at a fixed height above the terrain is very, very crucial, and the available online available digital elevation models for this part of the world are not acceptable, as the resolution is too high, and in a complicated terrain it could cause a crash of a drone. Okay, this is how ready for, this is an animation. This is an animation, but it shows the two stages of the field work. With red you can see the grid of the drone during the first flight, and then by creating a digital elevation model, the drone is brave enough to fly as low as it possible to the surface in order to produce almost microscopic pictures of the markers that I already showed you in the previous slide. For terrain follow mode, I used to fly with UGCS. This is a video. This is not a commercial video, but this is a real-time screen capturing of how the drone is performing in the real Antarctic field work. I will go forward. This is a 3D model of very complicated terrain. The maximum altitude is about 400 meters. And this model was created based on the multi-battery flight of 8 batteries were used, and then the images were stitched by Metashape, within Metashape. This is an example of a distance object which we examine and make a 3D model. There were several questions we were trying to find an answer. One of these is how about the approach to disembarkate by boat, and whether the access is safe, what are the elements we could see on the rocky face. This is a part of the orthomosaic produced after the flight, and this is a dike injection produced from an eruption of lava millions of years ago, and the takeoff point is more than 4,000 meters. This is the 3D model produced after the processing, and here, and at this stage I would like to show you how discouraging is this model. The overhanging ice is too much, and actually it is not possible to disembarkate here, as the amount of hanging ice is quite big. Maybe I should mention that the height is 125 meters from the sea level to the top, so this is at least 40 meters of solid compressed ice, where the density is about 940 kilos per cubic meter. This is really heavy. This is me at the field work. trying to compensate the backside wind, the tailwind coming from my backside. That's all from me. If you have any questions, I'm ready to answer.
Oleg, thank you for your presentation, and it's quite impressive. And we never supposed that it's so beautiful, but other hand, it's a dangerous work. How do you feel? What about wind speed, and what about weather condition? How do you work in these conditions? Any maybe tips or tricks how to use drones for in a high wind direction or something like that?
First of all, due to the very difficult access to the takeoff point or a suitable takeoff point, I consider or I reduce the number of drones I have I own, and limit my choice to Phantom 4 Pro and Mavic. Why? Because the access to all of these points is by foot. I mean, we have no vehicles available at this place, and such UAVs like Inspire 2, Matrix 200, they're out of our limit, as you have to carry lots of things. Secondly, we used to choose the conditions as gentle as they are, but being limited within the time we spend in Antarctica, so which is more or less 50 to 60 days within a campaign, the days suitable for flights is more or less 25%. The difficulties are coming from mainly from low cloud condition, as you see from this photo, and from the wind. We used to fly with about 50 kilometers per hour wind, and the drone resists at the course. But this is very critical for the management of the batteries. It is required to make some changes in the controller of the drones in order to increase the thrust power coming from the engines, in order to change the thrust to weight, self-weight ratio of the drone. And something that I'm very, very happy with the TOPODRONE solution is that the PPK upgrade is absolutely light. It doesn't change, it doesn't decrease the flight time. Secondly, not only the wind is important, but also the speed of the wind, but also the gusts. The gusts are very, very crucial. Sometimes there are 2 times, 3 times the normal speed of the wind. So these impulses coming from the gusts, they could land the drone very, very quickly. It is very, very, very interesting for taking off and landing in a boat during a high gusts. In all the cases, I'm talking about a rubber boat, not a ship.
Mm-hmm.
Did I answer your question?
Yeah, sure. It's very full answer for these questions. And what is your plans for future work? You show us penguins, which were the photo of penguins. Are you going to measure some number of penguins? How are you going to do it? I think it's very interesting.
Well, at the moment we have no automated way of counting penguin nests and determining the type of penguin within the nests. Mm-hmm. I could reverse to my photos. Okay, so the penguins grows very quickly. It is one of the wonder of the animal world, one of the wonders in the animal world in this part of Antarctica. The chicken is born in late November, and the chicken should be grown enough at the end of March, beginning of April, in order to swim or in order to spend in the open ocean for the next 6 months without being fed from his parents. But he has or she has to take care for food supply. So the chickens are evaluating very, very quickly, and there are several parameters which are crucial to the understanding whether the penguin population is in danger or is adjusting to the changes in the environment. One of these is to determine when the breeding, the nesting and breeding, where the border between the breeding and nesting. The second one is the second thing which is important, when the chicken is leaving the nests. What is the distance between the nests? But at the moment we use orthophoto, and by manual measurements we estimate this value that I mentioned.
Okay, and we have one more question. How the weather influences to the time of flight? For example, if the temperature is below zero, and how it influences to the flight missions?
The temperature, even in the best days, is below zero, and there is no significant reduction if the pilot prepared the battery with a suitable heat the battery before the flight. So usually I wear under my down jacket the battery for the first flight. So whenever I take off, the temperature of the internal temperature of the battery is about 20 or something like this centigrades. It is very important to put the battery in a plastic bag in order to avoid any humidity to get inside the battery. Otherwise, it could oxidize the pins, the golden pins of the battery. Then, when I put this warm battery, I take the next battery, put it in my jacket, and warm it. Usually the cold air is denser than the warm air. So due to this, it is assumed that the flight time is increased. On the other hand, due to the wind, the flight time is decreased. So a balance the balance is almost the same what you have here in this condition. But very important is to warm the battery before putting it into the drone. Nothing else.
Oleg, thank you for such very important tips how to use drones in very difficult conditions, and we wish you to continue your investigation in Antarctica, and we hope that our equipment will help you in the future as well. So we will provide you support, and thank you once again to join us. And we are moving to another one location. We are moving to another one country. We are going to make a new one presentation. Thank you, Oleg.
Thank you very much, Maxim. Thank you, TOPODRONE. Bye.
Thank you. Bye bye.